Okay, so what we've got coming up here is a conversation around this idea that there is more than one way to write an equation for a line depending on what information you are given. So at this point we should be pretty familiar with the slope-intercept form, y equals mx plus b. And the new kid on the block, so to speak, is going to be this one right here, point-slope form. Now point-slope form looks a little bit nastier than slope-intercept form, and it is, but it is nothing to be afraid of. And then lastly, we do have this other one here called standard form, which we are not going to be talking about in this class. But just to bring it up that there is a third form called standard form. And so let's begin looking at the differences and similarities between slope-intercept form and point-slope form. So slope-intercept form, if we start right here, you hopefully are pretty familiar with this, not necessarily from 8th grade like it says there, but from our class to this point. And the thing is that we need to know that this form uses the y-intercept and the slope to create an equation. That's why it's called slope-intercept form. We use slope-intercept form to describe a linear function when given the slope and y-intercept. And so again, that is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, point-slope form. It looks a little bit wacky and confusing. Let's go back up to it there. You can see it kind of at the top of the page there. But don't worry, it's not that bad. We use point-slope form when we are not given a y-intercept. And so you'll notice that in the point-slope formula up there, there is no b. There is just an m and what we're going to call a point, x1 and y1. And that point is a point that is not the y-intercept. So in the case that we use point-slope form, we are going to either be given 2 points or the slope and a point. So let's take a look at some examples of what we could be given and see what we should do about it. So there's a simple rule that we are going to sort of follow as we do this. And the rule is, if I have a y-intercept, I'm going to use slope-intercept form. So we need to ask ourselves constantly, do they give me the y-intercept or not? If the answer is yes, I have the y-intercept, I am going to use slope-intercept form. So let's take a look at the first one. Example 1, I have a slope of 2/3, and it crosses the y-axis at 0, 5. That is the y-intercept. So since I have the y-intercept, I am going to use slope-intercept form. And that would look like y equals mx plus b, which would be y equals 2/3 x plus 5, because y in the y-intercept happens at 5. So next we have a line passes through the point 3, 10 and negative 15, negative 2. Do we have the y-intercept? The answer is no. So in that instance, I would need to use point-slope form. Example 3, a line passes through the point negative 1, negative 1, and has a slope of 3/4. Again, no y-intercept, so I would need to use point-slope form. Number 4, a line has a slope of negative 4 and a y-intercept of 50. I do have the y-intercept, so I can go ahead and write an equation, y equals mx plus b. I would have y equals negative 4 over 1 x plus 50. And we'll practice writing the point-slope form equations in just a moment, but for now we're just identifying which form we need to use. So we got 2 points on number 5. I do not have a y-intercept. That is going to be point-slope form that I need to use. And then a line with a slope of negative 1/2 passes through the point 4, 2. I do not have the y-intercept, so I would need to use point-slope form on that one as well. Moving on. On the back, we'll get some practice writing equations that match these functions. And so for the first one, we actually already did that, and we knew that it was going to be in the form y equals mx plus b. So we would have y equals 2/3 x plus 5. Now we've got a line that passes through 2 points. And so we know we're going to have to use point-slope form. But what we need to use for point-slope form is we need a point, and we need a slope. And that's why it's named point-slope form. So for the point, we need to just pick either one of those 2 points. It does not matter. I will prefer to use positive numbers, so I will use 310. And then the slope, we need to remember that slope is y2 minus y1 over x2 minus x1. Here's our x1, y1, x2, y2. We've got y2 minus y1, so negative 2 minus 10, and negative 15 minus 3. So that puts us at negative 12 over negative 18. Or, if we simplify that, those are both divisible by 6, and they are both negative, so that's positive 2/3. So our slope is 2/3. Now, for the point slope form, we are going to be going y minus y1 equals m times x minus x1. And so we will have y minus y1 is 10, slope is 2/3, x minus x1 is 3. And so that, as crazy as it looks, is an equation that would represent this line. So, recognizing that this looks way more complicated than slope-intercept form, and we are going to be figuring out how to connect this more to slope-intercept form later, let's go ahead and look at our next one. Number 3, we do not have a y-intercept, so we do need a point and a slope. For point slope form. We only are given 1 point this time, so we don't have a choice. It's just negative 1, 1. And they do give us the slope this time. It's 3 over 4. So we can go straight to point slope form. Y minus y1 equals m times x minus x1. As always, super important to label x1, y1. There isn't a second point, so there is no x2, y2. So we've got y minus y1 is negative 1 equals the slope, which is 3/4, times x minus x1, which is negative 1. And as we have seen often with the distance formula or slope formula, we're going to end up with 2 negatives there, which will become positive, and 2 negatives there, which will become positive. So this is an equation in point and slope form that represents that line. Okay? Example 4. A line has a slope of negative 4 and a y-intercept of 50. So we were given the y-intercept on that one. We can go straight to y equals mx plus b. So y equals negative 4 over 1x plus 50. Pretty familiar with that one. Next, we do have only 2 points, and so we need a point and a slope. I'll do the work of finding the slope over here on the side so that I save myself room kind of on the inside there. We've got x1, y1, x2, y2. The slope is going to be y2 minus y1 over x2 minus x1. y2 is 5, y1 is negative 6, x2 is negative 4, x1 is negative 9. The double negatives I can change to be positive. And so I get 5 plus 6 is 11, over negative 4 plus 9 is 5. So 11/5 is our slope. And the point that we were given is negative 9, negative 6. Y minus y1 is equal to m times x minus x1. So our labels again here are very important. So y minus y1 is negative 6 is equal to the slope, which is 11 over 5, times x minus x1, which is negative 9. and those double negatives, they become positive. Okay, last one. A line with a slope of -1/2 passes through the point 4, 2. So we do not have a y-intercept, we need a point and a slope. Our point is 4, 2, and our slope is -1/2. So we can go straight to point slope form. Y minus y1 is equal to m times x minus x1. So we've got y minus, here's x1, y1. y1 is 2, equals our slope, -1/2, times x minus x1, which is 4. And as with the others, this is an equation that represents what's going on with that line.